liftoff on Apollo 11. Tower cleared.
Here we got a roll program. Houston, Apollo 11 is calling you on the high gain. How do you read, over?
Roger, loud and clear on the high gain.
Tranquility Base here. The Eagle has landed. It's one small step for man, one giant leap for mankind.
Welcome to this edition of NASA Images. I'm Lynn Bondurant. During this show, we're focusing on historic NASA documentary footage showing NASA technology spin-offs to medical and energy fields as well as others. Let's start off by going to a NASA report from 1979 about electric car tests.
This car, running on a dynamometer at NASA's Jet Propulsion Laboratory in Pasadena, is powered by a small electric motor and 20 batteries. It was designed and is owned by Wally Rappel, a senior engineer working on JPL's electric vehicle project. If large numbers of electric automobiles are needed in the future because of continuing oil shortages, engineers here and at other NASA facilities hope to be ready with the research answers that will make it possible.
I think the electric car probably will run, in terms of energy, just pure energy, about the same as a gasoline engine car. However, we're talking about energy displacement. The prime factor in favor of an electric car is that it can use any kind of energy to produce the electricity. Oil, coal, nuclear, even solar power, for example, can be used to produce the electricity which can then be stored in the car and used for power.
The assessment of current electric vehicles is being conducted by NASA for the U.S. Department of Energy. The research is expected to provide the focus and direction needed for future efforts. At a mile-long and infrequently used runway on the edge of the Mojave Desert, engineers prepare one of the electric cars for coast-down tests.
EV control to EV1.
Go ahead, control.
You ready to make a run? All right, stand by. On my mark. 3, 2, 1, mark. 15, 25.
Object of the coast-down test is to determine the electric vehicle's aerodynamic resistance. The test is performed by towing the electric-powered car up to about 60 miles an hour. At that speed, it's released. The tow vehicle is driven out of the way, and the electric car coasts to a stop. Both the velocity and distance are measured using a fifth wheel and recording device. This tells researchers the aerodynamic resistance and the rolling resistance of the car, both important factors in energy consumption. Another part of the program in the Mojave is the driving cycle test. The car is driven fast and slow, as if it were being driven in traffic. The car's energy flow is measured under this set of driving conditions, as well as the range that the car can achieve with fully charged batteries. Again, project manager Tom Barber.
The frequency of recharge depends very heavily on how the car is used, just as, for example, the gasoline mileage of your car varies depending on how you use it. If you use the car around town, you'll get probably 45 miles or so on a full charge. It takes approximately 8 to 12 hours to replace that full charge. On the open highway, for example, at 55 miles an hour, you might get as much as 75 miles, and the recharge time is still the same because you have to replenish the batteries.
Electric car research, an effort to find reasonable alternatives to gasoline-powered automobiles that may also be quieter and less polluting.
Not only was NASA involved with electric cars during the energy crisis, but also wind power. Later, during the next report, please notice that the blades of the large wind turbine machines are like wings in some ways.
Residents of this Rhode Island community can use steady ocean breezes to help air condition their homes in the summer or to heat them during the cold New England winters. They'll do it with a 200,000-watt wind turbine generator. The place is Block Island, about 35 miles south of Providence. This is the third experimental 200,000-watt wind machine in a 5-year wind energy program, a joint project of the Department of Energy and NASA. This New England island, like all windmill sites, was chosen because of its consistently high winds. The generator will electrify up to 250 homes during the winter. That's half the permanent residences on the island. Until the windmill, Block Island used all diesel generators for electricity. But now, wind energy and diesel fuel will work together to power the island. Block Island's winds should make it possible for the generator to operate at an average year-round output of 100,000 watts an hour.
Now, when we come to savings, it's directly proportional to the fuel. If this machine generates approximately 100 average, which it will, with 17-mile-an-hour wind, that would come to a considerable amount of fuel, 50,000 gallons, during the course of a year. And you simply multiply that by the present price, and you can see that it's substantial.
Block Island is not the only community boasting a new wind generator. Another windmill now towers majestically 1,000 feet above the mountain town of Boone, North Carolina. And the folks from Boone have lots to brag about because their windmill is the largest in the world. The blades alone weigh 18 tons. They spread 200 feet from tip to tip, about the wingspan of a Boeing 747. The machine produces 2 million watts of electricity, or 10 times as much as the other generators. Before the dedication, engineers tested the windmill from the control vans.
Okay, here we go. Monitor enable.
The electricity that's produced is cabled underground through the legs of the generator and then ties in here before it's sent down the mountain for distribution. Dedication Day was a big event in Boone. It was declared a town holiday, and everyone turned out to celebrate mountain style.
It's you on my pillow in all of my dreams. Another boy, big is a fiddler, trying to get a fiddler, trying to get a fiddler down. Another boy, big is a fiddler, trying to get a fiddler down. Another boy, big is a fiddler down.